For this week, when you go into Connect Math, you can look again at the Resources tab and do some practice. Now this week in Chapter 9, we're going to be looking at the paired data. So we're going to be testing the difference between two means dependent samples. Now technically, the mean difference and the difference in two means gives you the same thing, but the way you calculate the standard error is really a little bit different. But basically this is where we've got matched pairs or paired observations, and what I'm going to do is look at the preview assignment and go through a couple of examples. So when we start the assignment, it'll give us some exercises to work on that we can practice with. So let's look at the question. A sample of non-English majors at a selected college was used in a study to see if the student retained more from reading a 19th century novel or by watching it in DVD form. Each student was assigned one novel to read and a different one to watch, and then they were given a 20-point written quiz on each novel or each story. Assume the variables are normally distributed. The test results are shown below. At alpha equal to 0.05, can it be concluded that the book scores are higher than the DVD scores? Okay, so the idea is you've got book scores and DVD scores really for the same student. Remember, each student was assigned what? One novel to read and a different one to watch. So the 90 and the 75 are for the first student. The 86 and the 79 are for the second student, and so on. So this is a sample of a few students, and you've got paired data. You're pairing it by, you're taking two measurements on the same student. So at a 0.05 level of significance, can it be concluded that book scores are higher than DVD scores, right? On average, do students score higher when it's in book form as opposed to watching it on DVD? Now, mu sub d, okay, select the hypotheses and identify the claim with the correct hypotheses. Mu sub d equals 0. Okay, and that's not our claim. Our claim is that can it be concluded book scores are higher? So book minus DVD would be positive. That would support the claim. Okay, and the hypothesis test is it's one-tailed, one-sided or one-tailed. We're only trying to show that book scores are higher than DVD scores on average. We're not trying to say is there a difference either way. We're trying to specify book scores are higher. Okay, so we can click next. Okay, and then it's going to ask for critical values or whatever. Now remember, we're not really going to do critical values, but I'll sort of go through and look at how we could do that. What I want to do first is go and look at the download data though. So when you click download data, you can open in Excel or you can save it. What I would do is start by opening it in Excel. Okay. Now what I can tell is that there are 11 observations. Okay. Now if I were doing this manually, I would take the differences. I would take the 90 minus the 75 and get those values. What you should be able to do though in software is give it the two columns and let it sort of do all the calculations for you. So let's see what Megastat asks us for. It stopped working. And we'll close it and then maybe open it back up. So let's try this again real quick. We'll open it in Excel. I'll enable editing. And then I'm going to click Megastat. And this time, okay, I'm going to do, now, even though it says confidence intervals, I think everything goes under the hypothesis test. Okay, so paired observation. So that's what I want. So I want the data input. I have the raw scores. So group 1, okay, I put in. Then I click in the second one. I put in group 2. And it knows that it's paired data. So it's going to do all the calculations for me. Hypothesized difference. And close that. I guess that's a 0. alternative, not equal, that's not what we want. We want greater than. So you have to make sure HA is correct. And if you want the confidence interval, you'll have to click in this box. Okay, so if a question asks you for the confidence interval, act like you're doing a hypothesis test. Just make sure that you put a check mark in the box and select the correct level of confidence. And we're doing a t-test. Okay, so click OK. And what it'll do is it will go through and do all the calculations for you. Now n is 11, so degrees of freedom is 10. That's going to help me when I go and find the critical point they're wanting me to using that approach. What you're going to do really is look at these two lines from Megastat though, and if you were doing a confidence interval, you would look at those two lines. Okay, so the t-score is 3.73. That gives me a p-value of 0.0020. So if we go back to the data, if I looked at all the differences, okay, if I calculated, subtracted the two numbers on each line and looked at those and then analyzed those, I would get this type of output. So let's go back and look at the exercise in the homework, and remember it's a t with 10 degrees of freedom that we're looking at. So I'm going to minimize this now. Go back in here. Now the critical value. Now I'm going to need a t-table to get the critical value. Okay, so I'll go ahead and the t-distribution is table F. Okay, so I'm going to have to go through until I get to table F, and then I'll show you how they're doing the value for that. Okay, let me go ahead and make it a little bigger so we can read it. What we want is a one-tail probability. Whoops, got off the table. Go back to the table here. So we want a one-tail alpha of 0.05, and we want 10 degrees of freedom. So it's this blue line right there. So I should be using 1.812 for the t-score. Okay, so 1.812. If I go back to the exercise, and just make sure that if you're doing greater than, that'll be positive. If you're doing less than 0, you actually have to put a negative in front of that. Okay, and again, that's using the critical value approach. Actually, on tests and quizzes, we're going to do a p-value approach. Okay, compute the test value. Okay, so if I go back to the output in Megastat, that's the t-score, the 3.730. I can check that. Make the decision. So now the old approach, the traditional approach method, says if your t-score is larger, since this is greater than, if the t-score is larger than the critical value, you reject the null and you have proven the alternative hypothesis. In the p-value approach, you'd be comparing p-values instead of t-scores. So it really just depends on what you're comparing. They give you the same result. The reason that we used to do the critical values approach is because we didn't have technology that could get us probabilities based on the observed t-score all the time. Now we have computers and technology that give us p-values, so now people report p-values instead of comparing against critical values all the time. Make the decision. In this case, we are going to reject the null, so I can check that. And then there is enough evidence to reject the null hypothesis that the book scores are equal to the DVD scores. And that really is not a good summary. Okay, what you should be doing in a summary is talking about the alternative hypothesis. So what you should be saying is at a 0.05 level of significance, I can conclude that on average, book scores are higher than DVD scores. Okay, so I can click check, and then I'm done with that exercise. And notice it turns to a green check and everything. Now, another thing I can do is I can go back, I can take this data, and I'm just going to copy it, and I'm going to do the same analysis in Minitab. Okay, so I'm going to close these windows out to show you real quick how to do Minitab. So you can open Minitab or go to the virtual lab and open Minitab. And you can, if you have the file saved, you can open the file, or you can just copy and paste it from Excel. Now here you go to Basic Statistics to where it says Paired T. Okay, and then again each sample is in a separate column, so it'll do all the calculations for you. So I'm going to put book first, DVD second, then under options is where I specify everything. It'll give me a confidence level to use, and hypothesize difference. We're always going to use 0 for this course, and my alternative should be greater than. Okay, so I've got to select the greater than option there and click OK, and then click OK here, and this is your output. So you get a t-score of 3.73, p-value of 0.002. Now I know in the homework sometimes it asks for more digits. About the only thing I could say to do is take the 6.55 divide by 5.82, or really the SE mean is what you want to divide by, 1.75. So 6.55 divided by 1.75, and hopefully that would give you the correct answer to 3 digits. If not, you know, if you get close and I have to go back and give points because Minitab doesn't give enough digits or something, we'll just deal with that. But again, what I'm going to do is I'm probably going to give you either Minitab or StatCrunch output. I think the StatCrunch output is in tables and it's a little neater to read, so I'll probably give you that. So just watch the videos and make sure you can do it from the output. Notice that because we did a one-sided hypothesis test, it doesn't give you a confidence interval. If you want a confidence interval, when you do all this analysis under options, you have to make sure that the alternative hypothesis is not equal to. Then what it'll do is it will give you a confidence interval. Okay, so Minitab, if you're doing a confidence interval, that really is sort of equivalent to an alternative hypothesis that is not equal to 0. And that's what you would have to put in. So I think that pretty much concludes this example.